Welcome students to this second video covering digestion, turning a meal into cellular biochemicals, or better said, turning food into poo. In our last video, we talked about how our digestive system breaks down proteins. In this video, we will talk about how our digestive system breaks down carbohydrates, commonly called carbs. So just as proteins get broken down into individual amino acids, dipeptides, and tripeptides, as discussed in our prior video, carbohydrates are broken down into simple mono and disaccharides. The most common end products are glucose, fructose, and galactose, whose structures are shown here. By way of review, you might remember from chapter 10 that starch is comprised of 20% amylose, whose structure is shown here, and which has repeating 1,4-alpha glycosidic bonds, circled here in red, and 80% amylopectin, which has a similar structure as amylose, except every so often it has an alpha-1,6 branch point. See that? With that said, once complex carbohydrates that we eat, such as starch, represented generically by this drawing here, enter the intestine, they get broken down into mono and disaccharides by a pancreatic enzyme called alpha amylase, which cleaves starch's alpha-1,4 glycosidic bonds to form maltose, maltotriose, and limit dextrin, a material that cannot be digested by alpha amylase because alpha amylase does not have the ability to break apart the alpha-1,6 glycosidic bonds, represented by this kind of pink line here. We also get a little bit of glucose monomers out the bottom. Okay, now the alpha-1,6 glycosidic bonds have to be chewed up by a different enzyme called maltase. Other enzymes that include alpha-glucosidase, alpha-dextrinase, sucrase, and lactase then break down the polysaccharides that were formed by the initial breakdown further into individual monosaccharides. These monosaccharides are then released through the intestine wall and into the blood, where they can be picked up and used by other cells all over our bodies. For the sake of fun, because I think it's really cool and interesting, we'll now read the clinical insight from pages 285 and 286 of our text. Here goes. So, as you likely know, many adults are unable to metabolize the milk sugar lactose and experience GI disturbances if they drink milk. Why? Well, lactose intolerance, or hypolactasia, is most commonly caused by a deficiency of the enzyme lactase, which cleaves lactose into glucose and galactose according to the equation shown here. Now, deficiency is not quite the appropriate term because a decrease in lactase is normal in the course of development in all mammals. As children are weaned and milk becomes less prominent in their diets, lactase activity normally declines to about 5 to 10% of the level at birth. This decrease is not as pronounced with some groups of people, most notably Northern Europeans, and people from these groups can continue to ingest milk without GI difficulties. With the appearance of milk-producing domesticated animals, an adult with active lactase would hypothetically have had a selective advantage in being able to consume calories from the readily available milk. Because dairy farming originated only about 10,000 years ago, the evolutionary selective pressure on lactase persistence must have been substantial, attesting to the biochemical value of being able to use milk as an energy source into adulthood. So what happens to the lactose in the intestine of a lactase deficient person? Well, the lactose is a good energy source for microorganisms in the colon, and they ferment it to lactic acid while also generating methane, CH4, and hydrogen gas H2. This gas creates the uncomfortable feeling of gut distension and the annoying problems of flatulence. The lactate produced by the microorganisms draws water into the intestine, as does any undigested lactose, resulting in diarrhea. If severe enough, the gas and diarrhea hinder the absorption of other nutrients such as fats and proteins. The simplest treatment is to avoid the consumption of products containing much lactose. Alternatively, the enzyme lactase can also be digested with milk products. Isn't that fascinating? Well, thank you, my dear students, for watching this video. Please stay tuned to the next one, in which we will conclude our Chapter 14 coverage of digestion. Until then, have an enjoyable rest of your day.